能是这个现象发生在这里，也可能这个现象发生在下面。还是老师的想法是错的，你也可以指正我，没关系。
就因为一倍标准差里面的几率是68%嘛，那如果我今天
一倍，等一下，中心线到1倍不是68，是30，不是。
我是说正负1倍这样。
不，因为它一定是在这个 case 或这个 case 嘛，32，因为它一定是以中心线当做一个分水岭，对吧？那界限1倍标准差，它有可能是上面，有可能下面。还是杨丁认为呢 ？COW 你认为呢？对啊，因为它可能是在上面，有可能在下面。因为它不是68，它是68除以2嘛，对不对？68除以2嘛，0.34嘛，对吧？那它可能是，1、2、3、4，对吧？所以说它就会落在这个例子上面，因为都在这个上面嘛，对吧？或者是都在这个下面，所以说它可能是没有了，这个没有这样，应该是画上面这样子，这样的，这个是这样的，它是这样子，它可能是1、2、3、4、5，这边可能是1、2、3、4、5。
那不是，应该是4个点在1倍标准差外是吗？
我看一下。
4个有4个。
它是4 out of 5 plot at a distance of the 1 sigma。等一下，这个地方有一点，
那下面的图片也是最后4个点在1倍标准差外。
我看一下。
因为它是代表说它是这样子。它是什么？因它变成
叫上面先点出来。
所以它现在问题。
上面有4个，但是下面有1、2、3、4。
可是他不是看 center line 吗 ？center line 加1个它4个是超过，它4个超过1 sigma。
对。没事。
Beyond the one。
班长是对。
什么意思？
班长是对，因为我刚刚我解释错误。来，大家看到193页第3点，有没有看到？来，
有啊。
用荧光笔把它画起来，看一下哦。4 out of 5 consecutive point beyond 超过 beyond the 1 sigma limit， 所以说应该是1倍外面，刚好翻过来。那它也是会，
好啦，对不起。
那要怎么改呢？是不是变这样？这样就好了。啊？一样啊。因为这个是 P 嘛，这边不是就是1.P 嘛？哦，不是，1.1点 P 不是0.5减 P 啊。来，重新来。Two things are two-sided. For one case, this is 5, the 4 out of 5, and 4 out of plus out beyond the 4. Hold on. Yeah, check. 3 out of 5 consecutive points beyond the 1 sigma. Beyond the 1 sigma. 这个不要看，我们直接看193页的 Rule Number 3。4 out of 5 consecutive film a point beyond the 1 sigma limit. Beyond the 1 sigma limit, like this. So it's going to be right? Am I right? 0.16. And then, so should be there, then this would be 0.16 raised to the power 4 and the 0.34. Right? And this is the 5. 他刚好老师讲颠倒，他刚好是早晚。来，班长这样没问题。
那这样子图片前面5个点，这样算？
没有，你不要看那个点，那个会 confusing， 因为他写2个 rule， 你就看193页的，看193页。如果那么干，
完全一模一样。
所以这就是我如果点是有其中2个是在上1 sigma 以上的，就是大于中心值，然后在1 sigma 以外，然后另外2个是在。
哦，不行啊，他要连续5个点，中间4个啊。他讲的啊，又不是我讲的。没有，你可以设计自己的 rule， 只是有没有 make sense？
意思是说，就是它不能像前面这样一样嘛，就是其中有2个是在下面的，其中2个在上面。
不行啊。
哦，不是，其实没有说不行，只是这个 rule 是这样可以。你也可以定你自己的 rule，no problem。比如说，他的 rule 是他按照他是一个西方电子，我在1950几年就定出来。那大部分
对这个法，
我们都是超过3倍标准差，我们就警报，对不对？这是我们最常使用的。那因为有一些是没有超过，来看一下。
没有，你知道他的意思？他说有上有下，在这个法基本上
guys，
不能的。
说你用的同一些配内，但是你也有可以自己其实有这样子上下图，你也可以自己定一个法，我们没有一个对，只是在这个法定。
因为这个例子有没有任何点超出3倍？没有啊，没有。但是它是管制状态吗？没有啊，因为它还是 non-random。
因为它。
That's why we need to set up the Western electric rule for detection， 就是因为要设这个 rule 去侦测非随机。
对，前4点是方格。
这样可以吗？没有，不是说为什么？我的意思是说，他说一定是在这个 center line 的一边，
一定要在一边。
不是他的 rule 是这样，你可以设你自己的 rule， 不是？他的 rule 是这样设，他的 rule 是这样设，没有说你不可以，可以啊，可以啊，这当然可以。他的 rule 是这样。
水属，只是在用这个的。
我可不可以说 OK？
要在完。
我知道你卡住什么点，那你说5个点连续4个点，那我前面4个点连续3个点。或者是4个点，中间只有3个点，可以啊，你也可以这样算。我考试的时候我就会乱出嘛，你计算。这个是他讲的，我为什么发了？你也可以发我的、啊。这样懂吗？我只是讲一个例子，告诉你怎么说。
在这个用这个 C，
这样可以吗？
这个是用参与度的是要决定这个。老师因为他的入我是要4个，因为他有4个就在。就刚才他那个2是上下。
Okay. So it's going to be a very exciting examination. We're going to have a quite wide question to be asked. So you need to understand the detail. Then there's several exercises on the back. You practice makes perfection. 你练习你就会知道怎么做，那你管我题目怎么练，你只要题目看得懂，答案就会对，对吧？
没错。
So yes. 没有，不是要算什么，这个都是凹的看，也不会是，也不会是，不会是，不会是。
没有带水。干嘛现在？还是老师你忘了带水？为什么不带
Yes.
带到水
Okay, there's a sensitizing rule. Standard action signal. One remove point outside the control limit, quite obviously. And the 2 out of 3 consecutively point outside the 2 sigma 1 limit, but still inside the control limit. So this is trying point. 2 out of 3. Inside the 3 sigma, however, this is outside the 2 limit. A sigma, so you need to calculate the one-sided and multiply by 2, the same, right? Can you do that? This is 2 standard, like this. This is Starting to say 2 out of 3 outside the 2 sigma, outside the 2 sigma, and cell within the 3 sigma. So this is the 2 out of 3, right? Is equal to the 1. I'm going to calculate the probability within this, right? And this. The one-sided, this is one possibility, the other way, and multiply by 2. Question? Good. Actually the same. Yes. Do you have a question? No. Number 3, we have already expressed. Number 4, a run of the 8 consecutive point on the either side of the center. This is quite easy, right? This 1, 2, 3, 4, 5, 8 is raise the power 8, right? And multiply by 2. One side could be up or down. Consecutive is 0.5 raised to the power 8 and by 2. Right? Question. Right? 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 Okay, so remaining, you just figured out how to calculate those probabilities. I do not elaborate one by one. All right.
还敢租个电脑？家庭还敢租个电脑？没有，是被谁打出的？啊？不是被谁打出的？接下来就秒杀。
Out of control.
他被他在屌。
Miss COW saying yes. If we calculate that probability, then 1 minus alpha would be the income for that rule. Since we have a rule, right? Then for that rule, if we apply that rule, we calculate the probability to be non-randomness. Then 1 minus the probability is going to be in control. Yes. I say yes. Then, this is important. Will be in the examination as well. The equation 5.4. 这是新版的嘛？
它的中文字啊。
哦，差不多了。
跟图书馆借，感觉很有年代，都看好了。
So in general， 我那好像有一本，看谁要我可以给他，反正我都不要。
谢谢老师。
你们看谁先来找我 ，OK？ In general, care should be exercised when using several decision rules simultaneously, like Miss Cow just asking.
很老的吧。
If we set up two rules, for example, like班长 asking, if we will have a rule 1 and rule 2, for example, we need to simultaneously apply. Right. So process need to be in control. If the rule 1 is applied, simultaneously rule 2 is applied. Do you get it? Both rules should pass. Then we can calculate alpha. Suppose that K decision rule. Now we only have 2. For example, criteria I has a Taiwan arrow. So this is alpha 1. If the miscount is referring to that different standardized rule, we can calculate alpha, right? We can, right? And this is alpha 1 and alpha 2. So, what is that? The alpha overall, that means both should be simultaneously satisfied, right? Then, the multiply, multiply I equal to 1 to 2, for example, the 1 minus alpha. Why this is true? Things like this. If the alpha 1 is only 0.1%, alpha 2 is 2%. For example, both need to be simultaneously satisfied. So 1 minus alpha going to 0.99, right? And the 0.98. Satisfy this and satisfy this, so they need to multiply into that, and that will be the probability both rules are satisfied. Then use a 1 minus this. It could either you fail rule 1, either you fail rule 2, or you fail both rules. So there's a 100 probability minus both rules are satisfied. That's the only way you can pass. If the rule 1 you pass, however rule 2 you do not pass, you fail. Or rule 1 do not pass, rule 2 pass, or both rules do not pass. These three going to be the probability, the alpha overall. However, we don't do that. We do it in this way. We 1 minus only one way. Pass and pass. Then this going to be the alpha overall. Get it? 来看一下，我这里假设我有两个规则，我2个规则都要通过我的制程才被认为处于管制状态，对吧？好，现在要问了，我这2个规则，请问同时用的话，我整体的行因误差是多少？好，我整体的行因误差是不是有3种？第一个通过，第二个不通过。 第二个不通，第一个通第一个通过，第二个不通过，第一个不通过，第二个通过，或者是两者都不通过，这是我的 alpha， 因为我同时要这个。那我与其算这个，是不是用1减掉2个都通过结束？只要中间任何一个如果不通过，我就不通过了，是不是？我用8个 rule， 我只要一个没有 pass， 我就说这是 auto control。我只要用1减掉所有的通过，是不是剩下都是什么？我会 fail 的 probability。That's it. Then back to here. So provided K decision rule are independent, there's a very important assumption. And however, independent assumption sometimes is not a value usually with the usual center ties in rule. However, in the examination, you should assume they are independent. Furthermore, the value of alpha I is not always clearly defined for the center line rule because the rule involves several observations. So the further calculation is necessary. So, yes.
那个符号是什么？
相乘。
相乘。
相乘连乘积。来，我问你 ，Birdie。What is this?
连加。
Yeah. And what is this?
积分。啊。
What is this?
差。丢塔差吗？什么鬼？
Partial derivative.
哦，微
Partial derivative.
现在在上。
And what is this?
倒过来的。
What is this? Difference theta. Difference. 差分。这个是微分嘛？这是差分。
差分。
微积分应该都有教吧？
没有差分。
没有那么差。差分
应该没到那么好。
好。
这个符号差分吗？我们没有学到吧？在差分。没有啊，这好像没有学到。
好了。
这个差一点，跟第几就差一点点，差个分啊。
OK。Okay, phase 1, phase 2, 4.3.7. Okay, 5.3.7, phase 1, phase 3. The phase 1 is retrospective analysis. That means retrospective, like we turn our head to look into the past. How many historical data were collected? So data constructed trial control limits. So charts are effective in detecting large, sustained shift in process parameters. So in phase 1, we just look back how many data are available for us to construct the control limits. Then in this stage, we're doing the estimation of the parameters, and we do the outlier detection. Do you know what is the outlier, Miss Cow? Do you know what is the outlier to your understanding? The lady from Vietnam, do you know what is the outlier? No? How about that? Kelly, what do you think? Outlier? No? You? No? Computer science. What? 最高上限. Yeah, you can say that. You can say that. However, in industrial engineering application, typically we consider as okay, this is outlier. This is different from the major group. Totally different from major group. And measurement error, data entry error, etc. facilitates identification and removal of assigned costs. Sometimes if there's an outlier, we're going to stop the process and try to analyze and try to identify what is assignable cost that is corresponding to that outlier and that non-randomness. So it could be outlier or non-randomness. Non-randomness. So we also like to trace where does that randomness come from? Then, then first the control I use to monitor. Then we go online. We already understand the control limit is so trustworthy. Then that can put into the online process to monitor the process, and process assumed to be reasonable, stable. Emphasis will be placed on the process monitoring, not on bringing an unruly process into control. So 5.4, we're going to use for 7, very important on page 195.我们是下周期中考，
应该是吧？30看一下，
是不是？
对，下周。
下周。
是吗？
这就下了。
3个礼拜。
没错。下。
So the midterm will cover from chapter 1 till chapter 5.
到这一章了。
Yes, chapter 5. Okay, histogram and standard leave and check sheet. This is what we call the check sheet. The check sheet, there's a particular with respect to the defect data. So like the defect type, the part damage. So this is in the 2002 per month. This is I think the February only one time. The April 3 times, and so on and so forth. So this is called the check sheet. And then we just list all the names of the defect type, and then we mark it and to tally for by the January, February, March, April, or something. For this is by months, and this is by defect type, and totally this is by year. This is by year. Okay? Have a different statistic. That this is Pareto. Pareto based upon the 80-20 principle. So that means 80% of defective sources arise from the 20% of the defect. Like in Taiwan, the 80% of the I will not say that. It is not a good example. Or the 80% property was occupied by only 20% of the people or population. Yeah. And so we just rank it. This is Pareto. Then we just do it decently. We rank it. This is the highest, and this is the frequency, and this is part damage corresponding to 34 times. The third one is machining defect, 29, and so on and so forth. Then we can just totally, how many? Totally, for example, we have 200, so going to 36 divided by 200. Correspondingly, there's a relative frequency. Then we just apply. Then we just construct or plot the cumulative frequency, like this. So this is the cumulative frequency. Then, based upon the 80-20, 80-20, then we cut 80%. Then the for 3 defect type will accommodate 80% of the defect. So you just draw a horizontal since this is a cumulative frequency. So the example of Pareto, first of all, the component number is from the supply A or supply B. You can add them together, add them together or supply C, and using different color shade. And this example of the Pareto chart in C, or 80%, and where is the 80? Around here, this is 80%, and cut it, the first 3. The first 3 defect type accommodate 80% of the defects. Question? Okay, cause and effect. Cause and effect, this is called the Ishikawa or fishbone diagram. Then, so typically this is method, material, machine, and measurement, and personnel. So this is the defect. This is called the effect. This is called effect, and this is the possible cause. Can be the defect on 10 arise from method, the wrong work sequence of planning, material handling, and the defect can be due to the raw material defect from the supplier. Supplier provide low quality raw material, damage in handling, pen viscosity, and so on and so forth. Machine, the worm tool, too much play, and there's an agent or the surface finish of the pen flow rate, and this is the personnel, some absent-minded personnel, or the measurement incorrect or inconsistent specification or gauge error, or and so on and so forth. So typically, we're going to say that this is the person, this is human, right? And this is machine, right? Could be equipment or machine. And this is raw material, and this is the method. The measurement could be due to the environment. Okay, how to construct and cause and effects? Define a problem effect to be analyzed. So what is the effect? You just put in the fish head. Put in the fish head. 放在鱼头，你的问题放在鱼头 right? Then, from form the team, like a brainstorming team. This is form a cross-functional team. Some people from engineering, some people from equipment or the maintenance engineer, or some from manufacturing, some from R&D, and team to perform the analysis. Often the team will uncover potential causes through the brainstorming. 这是画起来 brainstorming. What is the brainstorming? 脑力激荡 Okay? Then, draw the effect box and the center line. So you have an effect. You have fish head, and you draw a line horizontally and specify the major potential cost category, join them as a box connected to the center, like this. Yeah, draw the box and connect to the center. Then identify possible causes and classify them into the category in step 4. Create a new category if necessary. It could be due to the other possible causes. You draw additional box. Then finally rank order the causes to identify those that seems most likely to impact the problem. So you're going to analyze one by one. If there's something which is very unlikely to be causing defect, then you just do not consider, and then you just rank that what is the most likely. And last one, take corrective action. We call the remedy action. So we need to correct that, remove the assignable cost, and the quality will be improved. Okay, defect concentration diagram. On the bottom of the page 199. So this is surface finisher. This is like a refrigerator. This is top view of the refrigerator. This is front view. This is the left side view. This is right side view. This is back. This is bottom. If there's some scratch, then we just put a mark on the view. So this is a surface finish defect on the refrigerator. So we just put here. If there's some defect, we just put a mark on that view. And defect concentration diagram for the tank. Then this is bottom, and this is top end, this is bottom end, right hand side, and left hand side. You just use illustration or 3D illustration, we would like to say 3D decomposition diagram. And then the defect code, we put an A as a scratch, the nick, and or the scuff, or the moon. Moon is an area. It's an area. 然后我们跟大家讲一下 ，scratch 就是刮伤，对不对 ？nick 就像一个针这样刺一下 ，scuff 是说就是好像被刮一痕 ，moon 就是整片，有时候喷漆有一整片不均匀，就像那个月亮啊，像那个月晕日阴一对不起月阴一样，就是那个月亮那个旁边有云啊。 就像晕晕的这块，它那个表面的喷漆不很均匀那种状况。Okay, then scalar diagram used for setting. Okay, bottom of the page 200. Okay, stop you.
这礼拜几？不对，6号有啊，在看哪个？5带3。好，谢谢。你看我条路。昨天看5条路。这个我知道。他应该出来，他应该考这个，他应该会这个你跟。
Okay,
Final 90.
No, I don't think it is a good idea. Okay, 5.26.
Oh.
27. And the 19. And 29. Okay, that's it. So that will be you next week.
19、26、27、29。等等回去。